Thank you. So, it's an app title showing where it comes from. Slide. Oh, I forgot to turn it on. Okay, so I'm Mr. Rios. You can look me up on socials. I don't have a QR code or anything. But just remember to put the two R's in the middle. My dad was not Mr. Rios. I'm Mr. Rios. So a little known fact that I completely made up is that William Shakespeare originally wanted to title his play Much Ado About None, but his publisher said no because Guido van Rossum wouldn't invent Python for another 400 years. Okay, so what do we have? We have nothing. You might think, no things, no problems, right? Well, nothing doesn't exist in nature. It's something that humans thought up. It's not a thing, it doesn't exist, you can't touch it. The problem with nothing is that, well, it doesn't open up a can of worms. It's not a Pandora's box because those things have things in them. The thing is that it's a concept. There's a void where there can exist a place where we don't exist, where there's absolutely nothing. It's the opposite of something, and it's a really horrible thing to think that there is like absolutely nothing. So here in this talk, first we're going to look at zero, representing nothing in mathematics because of historical reasons, as well as some philosophy, linguistics, and naturally move to computing. So you can tell your friends, I got nothing, I got nada, I got not, I got no, I got nil, I got zero, I got none. All right. The earliest recorded instance of nothing was with the concept of zero in ancient Babylonia. About 5,000 years ago, Babylonian traders in Mesopotamia were the first to use zero. But it wasn't a true zero, but rather a placeholder to separate numbers. I mean, they were doing business and you didn't want to get ripped off. So you added a placeholder to have 6,021 items instead of 6,221. But they never used a zero on the right side. It wasn't an actual digit, it was just like a placeholder. The convention was not used by the Western world at all. If you remember Roman numerals, there's no zero, there's no negative numbers, because they were using it exclusively for trading. The ancient Greeks did think up of zero, but they were like, you can't divide by zero, we can't use it. So they just ignored it. Half a world away, about 2,000 years ago, or 2,350 years ago, the Mayans invented their own numbering system. Astonishingly, this is a base 20 system, and the reason being is that 20 is the number of digits humans have, so the highest number you can use counting all your fingers and all of your toes. So we have here 0 as an actual number, it's no longer a placeholder. But on the right side you might think, well Daniel, you have a 1 above a 0, and that's true, it's a 10. But in the base 20 numbering system, a 10 is actually a 20. For example, when you have, when you're coding hex digits in HTML, you have, well, I don't need to explain it, but 10 is actually, oh no, I guess 10 is not 16. Anyways, you get the idea, you can do the computing yourself. Going around the world again, back to India, in Indian philosophy there's no problem with the void. In Hinduism, in Buddhism, you have rebirth, cyclical time, non-existence. You even have a god that's all about the void and rebirth and everything. So in contrast, the ancient Greek philosophy was that chaos was the beginning of the world until the gods came down and brought order upon everything. It was difficult for them to actually accept nothing, because of this thing. They didn't want to think about the chaos, they didn't want to think about the void. So in 650 Common Era, Brahmagupta, the mathematician, wrote the first mathematical guide, including zero as a digit. It was called Zunya. The book was called Brahma's Futa Siddhanta, the correctly established doctrine of Brahma. So marching forward through time and space, about 1825, the Persian mathematician and astronomer Muhammad ibn Musa al-Khwarizmi, and everyone should actually know this name, introduced the concept of zero to the Arabic world from the Indian mathematics that he had learned. His book was called Al-Khwarizmi on the Hindu Art of Reckoning. So in it he describes a numbering system recorded by Brahmagupta based on 1 through 9, the Romans had this as well, but with zero. He named the zero Cipher, and this numbering system quickly became the standard, but not in Europe. Remember, Europe was ruled by Rome at the time, so they're all using Roman numerals for trade. The drawbacks of the Roman numeral system come into clear perspective when you try to add the digits on paper. You have to cancel out any smaller digit that comes before a larger digit. So in this example, you cancel out the x's and you cancel out the 1 before the x. And from, 13 plus 99, you get 112. Oh no, that's wrong. That's 202. Is that right? Anyways. But the Romans didn't do errors in their mathematics like this. Instead, they used an abacus, which is an early form of an analog calculator, and then wrote down the result. They only used mathematics primarily for trading. So Europe would wait until the late 12th century when the mathematician Fibonnacci traveled the world. He traveled around the Mediterranean and North Africa and learned about the 10-digit numbering system. For him, it was very much superior to the Roman system. In 1202, he introduced his 10-digit numbering system to Europe in his book Liber Abaci, the Book of Calculation. And from there, the rest is history, right? Not quite. You do have another instance where zero was the main actor in a big event. In the 17th century, you had the invention of calculus. So the fight for who the inventor of calculus was fought out by Newton and Leibniz. Nowadays, when you have Newtons and Leibniz, you're thinking about cookies. But back then, it was a big deal. However, once you have a great idea and you release it into the world, there's no going back. People are just going to use it. So I won't get into the specifics of calculus because I'm not going to understand it. It's been more than 20 years since I even did any calculus. But if you don't have calculus, you don't have zero. And if you don't have calculus, you don't have an internet. If you don't have internet, you don't have Python. And if you don't have Python, you don't have none. So let's come out of history for a little bit, take a bigger perspective. We'll look at the journey of zero as a word. You have the origin of zero. It takes the path from Zunya in Sanskrit, top example, corrupted to the Arabic sifr, meaning empty, and this actually is the word from which ciphers come from. It takes a path through the French, but I'm not going to get into security stuff. Then to zephyrum in Latin, meaning zero, and shortened to zero in French, which is recognizable now as the zero we know in English. The word none, it comes from the Latin nullus, meaning not any or none, into the French null, and into the null that we know today. Another word for nothing has a similar journey, from the Latin nihilum, meaning not the least bit. So the word devolves into nil, and then nil, which is what we also use when we're describing nothing. You might have heard of a very niche philosophical concept called nihilism, coming from this word, the belief that life is meaningless, there's no moral code. So if you think about this, you can understand why people throughout history thought that the idea of nothing was a very dangerous concept. You also see the path of nothingness from the English words. You have none with its root in ne-an, not one, and from there you take that same word none to deny things, so you have none-thing, nothing. Okay, skip forward to 1966, so now you have computers using ones and zeros, no one has a problem with logic gates, no one has a problem with using digits to describe computational algorithms. So, in 1966, Sir Tony Hoare was working on an upgrade from Algo 60, trying to make it more human readable. He came out with Algo W, and in it, he introduced the very first instance of a null pointer. He says, I call it my billion-dollar mistake. At that time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. Has this ever happened to anyone? Type error, none type, attribute error, none type. By having a null value in our programming languages, we are indeed condemning ourselves to losing billions of hours, countless hours, billions of dollars, wasted in chasing down errors caused by an unexpected none. And usually when I get a none error, it's from a function 3 levels higher in which I forgot to, actually return a statement. So in modern computer science, we have 3 concepts to denote nothing. We have undefined, meaning the value variable hasn't been declared. You see this a lot in JavaScript. You can say the variable exists, but it won't actually point to anything. In Python, it won't work if you try to use it. We have null, or none as we use it in Python, meaning, the variable means nothing, like literally I don't know what I'm going to put in here, or just have nothing in the variable. And then there's void. Void is actually really confusing for me. I see it in Java, and the first time I saw Java, I was like, what does void mean? And they were like, oh, don't worry about that, don't worry about that. So Python doesn't use the void keyword, but instead if you want to declare that something returns none, you use a type hint. But I actually like none. It's a weird object, it's this weird contradiction, because you have to have something to represent the concept of nothing. So this is the ID for none on my computer when I was preparing this talk. Remember this number, because it's not going to change. So if you try to define a variable, like in JavaScript, it's not enough to just declare the type. Remember, type checking is done in MyPy, but not in actual Python. So you can declare box string, it'll be totally valid, but then when you try to call it, it'll be like, I don't have box. But if you first declare the variable to something such as none, you can easily reassign it, making it easier to work with variables when you don't know the value. So here I have box equals none, and then I reassign to box equals 5. You can do this because of Python's dynamic type system. Much better. Okay. So even if you declare a variable with a none type, here, we say some variable has a none type, it equals to 5. Python will let it go through. You type in some variable or return type. You check the type, it's an integer. No surprise because, again, type checking is not done in pure Python. But let's look at the same code in a file. So here, I'm showing you what's inside the file. It's the same code, some variable with the type of none equals 5. But if you run MyPy on it, MyPy says no, incompatible types in assignment. Because you've said that this variable is going to have none, but you declared something. Okay, what happens if you try to call none? Well, nothing, because none is not a callable. You can't actually call it. I find this error message really funny because it's like, perhaps you missed a comma, ? Okay, perhaps I did miss a comma. Let's try it out. None comma. Okay, we get a tuple. What use is that? Okay, let's try to reassign something to none. None equals 5. Okay, syntax error, can't assign to none. So, as an aside, Python has this concept of truthy and falsy values. So you can convert a Boolean to a number. Remember the ones and zeros in computing? So the integer of true is 1, the integer of false is 0. What's the integer of none? Well, it's not none, it's an error. But you can make none have a falsy value. Like when you check for none, you'll sort of treat it as false. So the Boolean of none is false, and if you try to have none in the set, and check it with all, it also goes to false because none is falsy. Okay, but none is not true. None is not false. It's none of these values. It's its own thing. So when you have a string, it's still none, but it's a string of none. So none is equal to itself, but more importantly, it is itself. In Python, this is something that's very separate. So remember this ID? Anyone remember the ID? No? Okay. It doesn't matter because it's not going to change, but I'd still like you to remember it. So we know that everything in Python is an object. So we check the type of none. It's a none type. What's none type? Let's check the MRO. Oops. It's consistent. Remember, everything in Python is an object. So the none type inherits from the class object, so none is an object. We check the directory of methods and functions. We have so many. But if you actually try to use them, we have here a class, for none, we have the dunders. You give this a none type. The Boolean returns false, the representation returns none. And it's 16 bytes of memory for this one object. But some of them are not implemented. None is not equal to 5, not implemented, instead of saying, false. None is not equal to the string 5, not implemented, but if you check none against itself, it actually is implemented. It gives you true. Why? No idea. It's one of those weird inconsistencies. Subclass hook, I have no idea what this is, but it's also not implemented. So none is an object. It has a none type class. Let's assign something to it. Setator, favorite number 5? Nope. You can't change none. Remember this ID? Okay. When you run the function, okay. So here we have 4 examples of functions that return none. The first one, we use pass. Pass is a keyword that we usually use if we don't know what we're going to actually write in the function. It's really useful for TDD. We have none print, where it will print something, but the thing is that you didn't actually return something. When I was a beginner, this tripped me up all the time. I would print 5, and I would wonder why, why can't I use this somewhere else? This is one of the reasons why you get a none type error, because you're actually doing stuff. And you're like, oh, I have all these numbers, but you don't actually explicitly say, give me this number. The third one, actually, you use a return statement. I use this a lot because sometimes in MyPy it says you forgot to include a return statement. Okay, but I was going to return none anyways. I'll make you happy and I'll type in return. And then the last one makes MyPy especially happy. You declare the none type and then you explicitly return none. So when we want to run the functions, what happens? In the top example, none pass will just return none, it won't do anything. None return returns none, and none print will actually print something. And this is very misleading if you're using the command line, because you'll think, oh, hello, nothing is the value that's been returned. And then none before, where you actually return none, has no output. So we're going to assign these to variables. Pass output, return output, print output, and none output. We call the functions, and then we compare them to each other. So I use the is comparator to actually check the address in memory. All these variables, pass output is return output, is print output, is none output, is none, are true. So my favorite thing about none is this exact same thing. None is a singleton, which means there can be only one instance of this object. The first time someone told me none was a singleton, I said, okay, because I didn't know what a singleton was. So if you don't know what it is, I'll tell you what it is. So first, any object created from the none type and any variable assigned to none will all point to the same object in memory, the same one object. Remember this ID? This ID will be the same for every single none that you instantiate and every none that you have. Okay, we instantiate a new none type, assign it to the variable new none. Check the type, it's a none type, so we got none. So let's assign our current none to the old none variable and check it. New none, is old none. Okay, you might think like, oh yeah, sure, it's all like none here. But in Python, when you declare variables that have the same values, it doesn't necessarily mean that they're going to be the same objects in memory. We have 5,000 equals 5,000, 5,002 is also 5,000. With the equal operator, it will say true. Those two numbers have the same value. But if you compare the variable 5,000 and ask if it's the same as 5,002 using the is operator, it'll say false. And the reason being is because of the IDs. These are the addresses and memories of the variables. And you'll notice they have 2 completely different addresses. So going back to our new none, our old none, our regular none, we check the values and they're all true. You might not believe me, but the ID is the same. We check the IDs of all the variables and it's exactly the same as this. Remember this ID? A singleton means there can be only one, and in this instance, there can be only none. Thank you.
We have some time for some questions if you'd like.
Sure, ask me nothing. Nothing? No? Oh, up there.
Hi, thanks for the talk, by the way. So you can can return a none, but you can also use none as a type int in Python.
Yes.
So do you know how that works? Because you can have none as you can return a none, but you can also have it as a type int, which is kind of weird because it's like an instance, but it's also a type.
Yeah, so what was the question?
So do you want, so I had a developer who was mainly a Java developer, and then they asked me, why can you return none as an object, but you can also type int none? So that was, I didn't have an answer for that.
This actually came up, I think yesterday we were discussing it, because usually for type hints you have the class or the representation of the object. I don't know. I mean, it's probably because none is a singleton, so you can't. No, you should be able to say, like, returns none type, but no one's going to understand that. So I think it's more of a convenience thing, to say, like, it will return none as a type hint. It's more understandable. And Python's about readability, understandability. So, no, but you're absolutely right. In Java, when I was doing what do you call it? A coding dojo, I was like typing void, and I was like, what does void mean? And they're like, oh, you're not returning anything. And I was like, well, do you return an actual value of nothing? They're like, just looked at me like very blankly. So I'm actually glad that it explicitly returns a value of, nothing.
Thank you.
I think we have time for one more very quick question, if we have any.
Does nobody got nothing? I can do these all day.
All right.
Or I can do them no days.
In that case, if we can get a massive round of applause for David Rios.
Thank you.